Now let us understand position time graph for various. It is initially at rest. It starts from rest. So initially at origin. So the position is changing along a curve and not a straight line. What was the significance or importance? V equals U plus AT. What are those terms? So slope of this straight line AB gives me uniform acceleration of velocity time graph. The slope of the VT graph Hello students, this is SD Sir coming back to you with a session further on motion in a straight line. Dear friends, in my previous session, I have analyzed the nature of motion. We have studied, we have bisected the nature of one-dimensional motion by studying VT graphs, the so-called velocity time graphs. In my today's session, again, I will study the nature of motion, exclusively the nature of one-dimensional motion by studying something called position time graph. We will understand what is position time graph. Draw position time graph for different situations. And most importantly, in my today's class, I will derive an equation of motion by using the velocity time graph. So, without any time lag, we will jump into our discussion. So, my first part of the discussion today, we will understand what is a position time graph. So if you observe here, again I have plotted a graph where along x-axis again I have marked the quantity called time, and y-axis I have marked the quantity called position. This is position time graph, xt graph, where time is plotted along x-axis and position along y-axis. If you remember our velocity time graph, again their time was plotted along x-axis, velocity was plotted along y-axis. In a xt graph, the so-called position time graph, time is plotted along x-axis and position is plotted along y-axis. So in simple words we say, any graph obtained or plotted by taking time along x-axis and position along y-axis is a xt graph, position time graph. Now let us understand position time graph for various situations. The first case, xt graph for a body which is at rest. I have to plot position time graph for a body which is at rest. I told with respect to position, what is rest? Any instant of time, any given interval of time, if the body is found in the same position, it is said to be at rest. So we told any time interval you consider, ಯಾವುದೇ ಒಂದು instant of time consider ಮಾಡಿದ್ರೆ, if the position of the body is the same, the body is found in the same position, then it is called to be at rest. Therefore, now again, along x-axis, time is plotted. Y-axis, position is plotted. Time interval I have taken in span of 2 seconds, 2, 4, 6, 8, etc. And position in span of 2 meters. When the time is 0, which means to say initially, to begin with, the position of the body is found to be 2 meters from the origin. After 2 seconds, kindly note, time has elapsed. After 2 seconds, still the position of the body is 2 meters. Again 2 more seconds, the 4th second, same position. 6th second, same position. So whatever is the interval of time, the position of the body is the same. Therefore, we say the body is at rest. So, how do I define rest from the given graph? Any interval of time, the position of the body remains same, then we say it is at rest. Next, xt graph for a body starting from rest. He says xt graph for a body starting from rest. Starting from rest andre, initially the position of the body is in the origin. It is initially at rest. It starts from rest. So, initially at origin and moving with uniform positive velocity. So, when we constructed VT graphs, I told uniform positive means along a straight line. So initially the body has to be in the origin, then its velocity has to increase along a straight line. Again, x-axis, time, y-axis, position, xt graph. Initially, the position of the body is found to be at the origin. As time increases, position also increases along a straight line, which means it has uniform positive velocity. Next one. XT graph for a body moving with increasing velocity. Dayavitu gamanisi. This is not uniform increase in velocity. He simply says increasing velocity. So it cannot be a straight line. See again, time along x-axis, position along y-axis. Now slowly from the origin, as time is increasing, as there is an increase in time, slowly the position of the body also increases, and this increase is not a straight line because this is not uniform increase in velocity. It is simply increasing velocity. So the position is changing along a curve and not a straight line. Next, naturally, this is XT graph for a body with decreasing velocity. My dear students, what was the significance or importance of velocity time graph? The slope of the VT graph gives me the acceleration of the body. Then what is the significance or importance of an XT graph? Slope of the XT graph gives me the velocity of the moving body. Do remember, slope of VT graph gives me the acceleration, whereas the slope of the XT graph gives me the velocity. Now, this is a very, very important derivation. Now, by graphical method, that is, using velocity time graph, I have to derive the first equation of motion, V equals U plus AT. There are three equations of motion, three equations which mathematically describe the nature of motion of a body, out of which the first equation, fundamental equation, is V equals U plus AT. What are those terms? How do I define those terms? I will be explaining through the graph. So using velocity time graph, VT graph, I am deriving the first equation of motion, which is V equals U plus AT. Velocity time graph modale odidivi. Along x-axis, I plot time. Along y-axis, I plot velocity. Alva? Velocity time graph andre x-axis ಅಲ್ಲಿ time ಅನ್ನು ಪ್ಲಾಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ, y-axis ಅಲ್ಲಿ velocity ಪ್ಲಾಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. Now, to begin with, initially I will consider a body which is at rest. So since I say the body is at rest, its position has to be at the origin. When time t equals 0, see in physics, it is absolutely nonsense saying t equals 0, time equals 0. The statement only correlates saying that at the beginning, initially, to start with. So, to begin with, the body is at rest. Since it is at rest, its position is marked at the origin. The position of the body is at the origin. Now, as there is an increase in time, the body starts to move with a certain velocity. Time increase ಆಗ್ತಿದ್ದ ಹಾಗೆ the body moves with a certain velocity, reaches the point A with a velocity u, what I call as the initial velocity of the body. Initial velocity, starting velocity. So u represents the initial velocity of the body. Now at A, the body is displaced uniformly along AB. Displaced andreno, changes its position. So yes, is the uniform displacement, which means along AB, the body has uniform acceleration. So once it has reached the point A, it uniformly displaces itself along AB, and along AB, it has uniform acceleration. And finally, BD is the final velocity of the body. Therefore, when I equate or explain the terms, OA equals U, initial velocity, BD equals V, final velocity. So BC, so from the graph if you observe BC, it is BD minus CD. So this is V minus U. And AC equals OD, which is T. Now, I want to calculate uniform acceleration. Body is displaced along AB, uniformly accelerated along AB. So slope of the straight line AB gives me uniform acceleration. Your high school geometry, how will I find the slope? Slope is nothing but tangent. Slope of a straight line is nothing but tangent of that straight line. So slope of the straight line AB is nothing but tangent of the straight line AB. So tangent of AB, I have a right angle triangle theta, tan theta ಕಂಡುಹಿಡಿಬೇಕು. BC by AC, opposite side by adjacent side. Slope of the straight line AB giving me uniform acceleration. Tangent of the line AB, which is BC by AC. Therefore, BC by AC is V minus U divided by T. You can clearly see here, BC is V minus U, AC is T. So BC by AC, BC is V minus U, AC from the diagram is T. Cross multiply, AT is V minus U, or V equals U plus AT, and this is the required expression. My dear students, if you analyze here, the first equation of motion is independent of the distance traveled. It is only in terms of final velocity, initial velocity, acceleration and time. So I have derived the first equation of motion using VT graph. In my next session, I will come back with the second and the third equations of motion. Dear students, success has many attributors. Failure is always a self-blamer. It's the right time. Click on to success. Be responsible for your success. Before we meet in the next session, thank you.